Welcome to this exercise section on trigonometric functions. And we're going to do quite a few problems. We're going to start out with this one, where it says, find all 6 trigonometric functions of theta if the given point -3, -4 is on the terminal side of theta. So what I'm going to do with that -3 and -4, I'm going to go to Paint. And I'm going to graph that. So let's see, -3. And I think I'm going to use red for that. And we're going to do -4. There we go. And it doesn't allow me this line, so I'm going to do this here. I'm just going to raise it in between. There we go. Oh, that's good enough. And then I connect them here. And of course, it's a nice Pythagorean triple, so I know that the hypotenuse is going to come out to 5, no matter that the adjacent and opposite are negatives, because as you square them, you get rid of that negative. Okay, we're supposed to find all 6 trigonometric functions. Notice also that we're in the third quadrant, so what we know about the cosine and the secant is that they need to be negative. What we know about the sine and the cosecant is that they need to be negative. What we know about the tangent and the cotangent is that they're actually positive. For the sine, what we're going to have is, well, -4 divided by 5. For the cosecant, it's a reciprocal, so it's going to be 5 over -4. For the cosine, it's going to be -3 over 5. And of course, for the secant, it's going to be 5 over -3. For the tangent, it's going to be -4 over -3, and for the cotangent, -3 over -4. Let's go back to Word. And I just jot down what I just said. So for the sine, it's going to be the opposite, -3, divided by, I'm sorry, not -3, -4 divided by 5. For the cosecant, it's a reciprocal, 5 divided by -4. For the cosine, it's the adjacent, -3 over 5. For the secant, it's the reciprocal, 5 over -3. At this point here, this will be true always, that for the sine, as we come up with -0.8, and for the cosine we come up with -0.6, that the sine and the cosine are always between -1 and 1. For the cosecant, we come up with -1.25. And here we're going to come up with -1.67. For the cosecant and the secant, it's always -1 or smaller, or +1 or larger. So it's never in between -1 and 1. That makes sense because they're reciprocals of sine and cosine. For the tangent, we had -4 over -3, which comes out to a positive 1.33. For the cotangent, it's reciprocal, -3 over -4. I hope you don't hear too much of this background noise. These are all instructors at UAA having with time early in the morning during the symposium where they're joking around. For the tangent and the cotangent, which are, of course, also reciprocals of each other, they can take on any values between 0 and infinity and 0 and negative infinity. Okay, next problem, really similar. Find all 6 trigonometric functions for if the given point 0, -5 is on the terminal side of theta. So what we have is we have 0, I'm sorry, that's not true, -5 divided by 5. We have 5 divided by -5. We have 0 divided by 5. We have, ooh, interesting, 5 divided by 0. We have -5 divided by 0. And we have 0 divided by -5. So we're going to come up with -1. We come up with -1. We come up with 0. We come up with undefined. We come up with undefined. And we're going to come up with 0. Let's go over to Paint and look at that. So what we have here is 0 and -5. So we're here. Really doesn't look like a triangle, but we could imagine that the adjacent is 0, which it is, and the opposite is -5, and that also means the hypotenuse, so to say, is 5 as well. Respectively, I keep talking about the adjacent and the opposite. That's really the definition that I prefer. It'll come up later. In this case, it's the side R, which is basically the hypotenuse. Okay, and as you can see here, we would have to divide 0 by 5 in order to come up with the cosine, and 5 divided by 0 to come up with the secant, and so on for all the other functions. Well, I'm in Paint. Let's do the third problem that's similar to this, where we have find all 6 trigonometric functions for -3 and the square root of 7. So I'm going to go with -3. There it is. And the square root of 7, which should be 2 point something, 2.6. So I'm going to go up here, 2.6, looks like around here. Here we go. Make a few dashed lines here. There we go. And then we connect here. Okay. For the cosine, we're going to get -3 divided by, oh, the hypotenuse. Let's calculate what the hypotenuse is. That's going to be -3 squared, which is 9, plus square root of 7 squared, which is 7. So we come up with 16, which means that the hypotenuse is going to be 4. So we are going to have for the cosine -3 over 4 for the secant, 4 over -3 for the sine, 2.6 divided by 4 for the cosecant, 2.6, I'm sorry, 4 divided by 2.6 for the tangent. We'll have 2.64 divided by -3, and for the cotangent, -3 divided by 2.6. And you can see that as we're in the second quadrant here, that the sine and the cosecant are positive, the cosine and the secant are negative, and the tangent and the cotangent are negative as well. So let's go over to Paint, my Word, and plug in our results. So here we're going to have 2.64, well, I guess around 2.65, divide by 4. 0.66 cosecant 4 divided by 2.65, which is the reciprocal of that, looks like 1.33, no, 1.50, sorry, 1.50. Notice both are positive, just like we figured they should be in the first quadrant. For the the second quadrant, for the cosine and secant in the second quadrant, both of them will be negative. So here we have -3 divided by 4, -0.75, and here we have 4 divided by -3, which is -1.33. For the tangent, we have 2.65 divided by -3, which comes out to -0.88. And for the cotangent, we have -3 divided by 2.65, which is the reciprocal of that, which comes out to -1.13. With that, I will actually interrupt myself. I said I'm recording this with all these other instructors around here, and I need a break, and then continue on with these here later. In the meantime, I will paste these images that you just saw that I drew on Paint. See you in a while. Welcome back to exercises for this section. In the meantime, I have pasted the diagrams that I had earlier, and I guess the only thing that I could have added here in the diagrams would be to write -3 on here, and -4 and 5 for the hypotenuse, and then here -5, and here -3 and positive 2.65, I believe that was. But I believe that you can see that. So let's go ahead with some exercises. So I'm going to scroll down here quite a bit. And it says, draw the angle of 135 degrees, which we know is in quadrant 2. Find the sine, the cosine, and the tangent. So I'm going to go over to Paint. There we go. So it says 135 degrees, which is in quadrant 2. And it's kind of nice because in quadrant 2 here it's a 45-degree reference angle, so it's relatively easy to draw. To indicate the angle, I'm not sure how good I will be able to do that. That's not too bad. Yeah, there we go. That's not too bad. Okay. We're supposed to figure out what the sine, the cosine, and the tangent are. So the sine would be for this angle as I'm taking this one here, for example, 3 out, and then I go 3 up here. There we go. So what I do now with that is that I can say, okay, for the sine, that will be 3 divided by the hypotenuse. As I said, I just did this arbitrary here. And the hypotenuse would be 3 squared plus 3 squared. Take the square root of that. So the square root of 18, for example, which is, I believe, 4.5. No, not quite. 4.2. So it will be 3 divided by 4.2. However, it is easier to assume that I have ones here. So I have 1 and 1. And then that makes the hypotenuse an easy square root of 2. And then for the sine, I would simply have 1 divided by the square root of 2. For the cosine, I would have negative 1 divided by the square root of 2. For the tangent, I would have 1 divided by negative 1. So it's sometimes easier to, instead of using an arbitrary number, to use fixed numbers, easy numbers such as 1, negative 1. So let me go back to Word and fill it in what we just found out. So we have 1 divided by the square root of 2. And I have to get that square root symbol. It's a little sluggish here. Word, there it is. Alright, hopefully, maybe. Still thinking. Alright, back. Which comes out to 0.707. For the cosine, it will be negative 1 divided by the square root of 2, which comes out to negative 0.707. That was at 45 degrees, or referencing all 45 degrees. Cosine and sine are the same. Tangent is going to be 1 divided by negative 1, which of course is negative 1. Draw the angle theta 225 degrees. Find sine, cosine, and tangent. That's in the third quadrant. Again, the reference angle is 45 degrees. And when I mention reference angle, that's from a later chapter, but I might as well use it right here. In the third quadrant, the sine has to be negative, and it's going to be a, for example, negative 1 divided by the square root of 2, negative 0.707. And I better double check myself on that. Yep. For the cosine, third quadrant is also going to be negative, so it's negative 1 divided by the square root of 2. Comes out to negative 0.707. I just would like to put a 0 in front of that. And for the tangent, it's going to be negative 1 divided by negative 1, which equals positive 1. Let's go over to paint and draw that. So 225 degrees. Here we go. There we go. And again, if I take some kind of unit vector here of that I consider to be negative 1, and then here I consider it to be negative 1, or to give myself a nice hypotenuse of square root of 2, and then I go in there and I draw the angle. There we go, 225 degrees. That actually looks pretty good. So here for the sine, it would be -1 divided by square root of 2. For cosine, -1 divided by square root of 2. And for tangent, -1 divided by -1. Just like we concluded a moment ago. Okay. Let's see, next problem. Which says, find the remaining trig functions if sine theta equals 12/13 and theta is in quadrant 1. So let's go back to paint. Let's see, it sure looks like I need more space, so what I'm going to do here is I'm going to take this one out. Now, I think what I'm going to do simply is I save this, what I have here, in the file, so I don't lose it, so please bear with me for just a moment. There we go, and open a new one for myself. There we go. Okay, it says that I'm supposed to find the remaining trig functions if sine theta equals 12/13 and theta is in quadrant 1. I'm going to use the lower one here where I have 12 and 13, so I draw 12 here. Let's see, and I'm not going to do that in black. Again, I'm going to do it in red. Three, 6, 9, 12. There we go. And I will do it once again and make the line thicker. There we go. Whoa, now it's really thick. 12, 3, 6, 9, 12. I will erase this one here. There we go. Okay, I will do 13 from here to there. And then I guess so what I have here now is 12 divided by 13. How do I know that this one started out over here? Well, because I know that for this kind of Pythagorean triangle, I have 13 squared equals 12 squared plus whatever this one here is. And when I do the numbers relatively easily, I will come up with 5 squared. So that's why I started here at 5. So here I have this one here. There you go. And do this one. And I'm supposed to figure out what the remaining trig functions are. Well, they're simply going to be the cosecant is the reciprocal of that, 13/12. The cosine is going to be 5/13. The secant is going to be 13/5, the tangent is going to be 12/5, and the cotangent is going to be 5/12. So relatively straightforward. While I'm here, I'm going to do the next problem, which says to find the remaining trig functions if sine theta equals 12/13 and theta is in quadrant 2 this time around. So I'm going to go to the next graph, and I'm going to graph here, there, and there, and there, and again I can use the eraser. There we go. And I guess I get rid of this And I will do one more thing, which is show where the angle is. So this is the angle. Whoops. Chose the wrong one. Do it again. So there's the angle. There's the angle on this one here. If we actually want to know what the angle is, this one doesn't look too easy. What is it, 60, 70 degrees or so? It's in a later chapter where on our calculator we would have to take the inverse sine of 12 over 13. I didn't open my graphing calculator for this session, so I'm going to do this on the side here. I come up with 67 degrees when I take the inverse sine. As I said, I will show that in a later session. Actually do an M. So this one here is actually 67 degrees, and this here would have to come out to 113 degrees. Okay, let's go back. Oh, now what I have to do here is, well, find out again what are all the others. So sine theta equals 12 over 13 in quadrant 2. So cosecant theta is 13 over 12. Cosine theta is negative 5 over 13. And secant is 13 over negative 5. And tangent is 12 over negative 5. And so on. So I go in here and plug in all the results that I just came up with. So sine, of course, is 12, 13. That's the reciprocal. This one here is 5 over 13. This one here is the reciprocal. This one here is, let's see, 12 over 5. For some reason, this one here is 5 over 12. Just want to say that my computer here was a little sluggish. I need to update something, I guess. And then next problem, I just copy and paste it here, but I'd have to pay attention to that the cosine, for example, is a negative 5 over 13, secant 13 over negative 5, tangent 12 over negative 5, cotangent negative 5 over 12. And we're done with that, with these two exercises. Find theta in quadrant 3 for tangent theta equals 1. So let's see what we come up with. And then I'm going to also do find theta for cosine theta equals negative 1. So I'm going to do these two here in Paint. So what I have here is theta is in quadrant 3 for tangent theta equals 1. So I'm going to go in there. And I know that theta has to be, tangent has to be 1 if the opposite and the adjacent are of the same length. And that only happens at a 45-degree angle, respectively, since we are in the third quadrant. That will then come out to, let's see, 90, 180, 225 degrees. And the other one was find theta for cosine theta equals negative 1. It didn't say what quadrant we're going to be in, but there is only one possibility for cosine to be negative 1, and that is to the straight to the left. And again, the angle would come out to this one, which is 180 degrees. Oops, sorry about that bump there. Let me see if I can. Let me see if I can do this a little nicer. There we go. So I go back to Word and fill in our answers. So here we come up, find theta, and that came out to 225 degrees. Let's see, I do this again here. I don't know if I copied this actually. 225 degrees, and this was theta. And for the other one, that came out to 180 degrees. Okay. Last problem, which says find sine theta and cosine theta for theta in quadrant 3 along the line y equals 2x. So let's go over to Paint. And let's see if I have anything left here to work with. I really don't, so let me save this one. Just takes me another few moments here. There we go. Okay. So we're going to have y equals 2x, which means slope of 2. I'm in black again. Oh well. So that's a slope of 2. I'll switch it to red now. But of course I'm supposed to be in quadrant 3, so I'm going to be over here. Yep, that's pretty good. Okay, the angle and therefore will be over here. How does it look like? Well, if I do it on my calculator on the side, what I would have to do is I would have to do, for example, -2 over -1 and take the inverse tangent of that. They're not asking for that, but I'm just curious what the angle is, and my calculator gives me a 63 degrees, which is a reference angle, so it should be 243 degrees what we have. Yeah, that's kind of how it looks like. Anyway, we're supposed to figure out what the sine and the cosine are, and what I have here then is, example here, I might have a -1 here, and then I have here a -2. That means my hypotenuse is going to come out to the square root of 5, right? -1 squared plus -2 squared is 5. Take the square root of that. So my cosine will come out to -1 divided by the square root of 5. My sine will come out to -2 divided by the square root of 5. So I'm going to put in the answers. So let's see. This one is going to come out to, I just said, -2 divided by the square root of 5, and cosine equals -1 divided by the square root of 5. And with that, I'm done with the exercises for this section. Okay, welcome to this session that is actually a little addendum to this Chapter 1.4 problem section. Want to do it a little bit different, a little bit along the lines the way the book wants us to do and the way you should understand it. So it says, problem K, find the remaining trig functions of theta if cosine theta equals square root of 3 over 2 and theta is in quadrant 4. First of all, I'm going to go to painting program, and in the meantime, I'm recording this in late January of 2008. I've switched to a different painting program, which I'm trying to find here. There we go. This is the Smart notebook that I didn't have available or wasn't aware of it when I first recorded my sessions. In any case, it said cosine theta equals the square root, and I don't know how to type this here, square root of 3 over 2. Let's see if I can have some kind of put my theta in here. I guess I can do that. Okay, I don't know about the rest here, so I just leave it at this here. So cosine theta equals square root of 3 over 2. This is the same as x over r. So I'm going to go in here and actually draw this down. X is square root of 3, which is 1.7 long. So this here kind of looks like this would be 1.75. So about a little more than 1.7, right? So about there. Then r is too long. I mean, not too long, but r equals 2. Actually, I'm going to use this ruler here. And because it's a quadrant 4, this should point into quadrant 4. I still need to grab the ruler here. And it's supposed to be too long. I'm sorry, r equals 2. There we go. And I'm trying to line it up with the terminal point here of x. That's why it takes me a moment here. Yep. I don't think I can make it any better. So here we go. So r equals 2 right there. Just out of curiosity, I can also, measure the angle. There we go. Yeah, 30 degrees, which actually turns out to be correct. We'll see that in an upcoming section. And then I'm going to do the third side, which is right here. So here we go. I'm going to move the protractor out of the way. And so here what we have is x equals the square root of 3, which is roughly 1.7. And here we have r equals 2. And I don't know how good this shows up, so I'll make it a little larger. Here we go. So I'm going to make this a little larger. There we go. All right. And then y over here. Well, we have Pythagorean triangle. So we're going to do 2 squared minus the square root of 3 squared equals, and then take the square root of that. And when we do that, that's going to be 4 minus 3, which is 1. Take the square root of it, and it comes out to 1. And if you look at that ruler that I have here, right there, and I'm going to right there, and I'm going to turn this, and you can see that this is, the side here is 1 long, and it overshoots a little bit, but that must be me drawing, so I was a little bit inaccurate in drawing this. Okay, in any case, we have x equals 1.7, r equals 2, y equals 1, and I'll take that back because that's a negative 1 because it points into the 4th quadrant. So here are the 3 numbers that we have, and I'm going to go back to Microsoft Word, and I'm going to put that in there. Let's see, there it is. Okay. So what do we just say? This one here is the square root of 3. There we go. Y comes out to negative 1, and R equals 2. And now the rest, after having gone through these kinds of motions, the rest is just plugging in these three numbers here for the respective trig functions, as we learned from the definition given in this section. So it's just type in negative 1 over 2, square root of 3 over 2, of course there it is, and negative 1 over the square root of 3. There we go. And that actually might be expressed a little bit different because, as you know from algebra, we like to get rid of the square root when it appears in the denominator. So build it up by multiplying the whole fraction with square root of 3 in both the numerator and denominator, and we're going to come up with minus the square root of 3 over 3, and there's that minus. And then the reciprocal functions are just, well, the reciprocals of those numbers, so it's going to be a minus 2 for the cosecant. It's going to be a 2 over the square root of 3 for the secant, but again, that would be written without the square root in the denominator, so build up the numerator and the denominator with the square root of 3, so it's going to be 2 times the square root of 3 over 3, and the cotangent is going to be the negative square root of 3, the inverse of, or the reciprocal of tangent. And so that's how that kind of problem would be tackled. And it looks a little bit nicer having that drawing in the back of our minds, respectively, in the paint program that I just used, and figuring out x, y, and r, and plugging them in here for using the definition for these trig functions. And that was it.